Hello viewers, in today's lesson in chemistry, we are going to be looking at Boyle's law. In the year 1662, Robert Boyle stated the relationship that exists between the volume and the pressure of a given mass of gas. That is, what happens to the pressure of a gas if its volume changes, or how will a change in the volume of a gas affect its pressure. So, looking at the volume of a gas first, we know that a gas has a negligible volume relative to the container. When you pump a gas into a container, the gas occupies the entire space of the container. So the space occupied by the gas is referred to as the volume of the gas. Moving over to the pressure of a gas. In gases, the molecules are far away or they are far apart from each other and they move randomly in different directions. And as such, they often collide with each other and also collide with the wall of the container in which they are present. So the force exerted by these gas molecules due to that collision between the gas molecules and between that of the gas molecules and the wall of the container is what results in the pressure of the gas. So now I've really stated the volume of a gas and the pressure of a gas. Let us consider a gas contained in a vessel enclosed with a piston that can be made stationary or moved up or down. So the space occupied by the gas is referred to as the volume of the gas. So I can call this V1, which is initial volume. And the pressure of the gas, I can call it P1, sorry, which is the initial pressure. Now what happens if the volume of the gas increases, the space occupied by the container increases? Let's see what happens. As you can see, when we increase the space occupied by the container, that is when we increase the volume of the gas molecules are further away from each other. And since the distance between the gas molecules have been increased, which means they will collide less often, the collision between the gas molecules will reduce, and as such, the pressure will also reduce. So what do we notice here? What can we derive from this? We can see that an in volume increase in volume of the gas results to decrease in the pressure of the gas. Likewise, a decrease in the volume of the gas will result to an increase in the pressure of the gas. So we can call V2 the new volume and P2 the new pressure. So this illustrated here is a type of variation or proportionality which we call inverse variation, in which as one quantity increases, the other decreases, and vice versa. So in Boyle's law, as the pressure increases, the sorry, as the volume increases, the pressure decreases, and as the volume decreases, the pressure increases. So stating Boyle's law, we have that Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature remain constant. Yes, the temperature of the gas itself has to remain the same throughout the entire process. And that means, so with that, we know that the volume is inversely proportional to the pressure. And to remove this proportionality sign, we have that V equals K over P, where K is the constant of proportionality. And doing that, we have that when we cross multiply, we have P times V giving us PV equals K. So this is the relationship between pressure and volume. Now, since we had initial volume and initial pressure changing to a new pressure and new volume. We can now have that P1 V1 equals P2 V2. So this is the mathematical expression. This is the mathematical expression for Boyle's law. I hope you understood everything I explained here. See you in our next class. Thanks for watching, and remember to click the subscribe button.